Okay, so let's see this in more detail. So we have this empty string and we move towards empty string. So we have no operations. We have this I, we move to empty string, we delete one. We have empty string, we move to another string with E, single character, we insert one. Right now, suppose we are having initially we are having I and we have to move to E, right? So in this case I may apply a substitution. Just I am replacing E with I, or I may apply this one, delete I here, delete I plus insert E, right? So I may apply a substitution, or I may apply this delete I plus insert I, or I may apply insert E plus delete I. So there are three paths for I to E. We have three paths, right? So we can directly substitute. Okay, what is the substitution cost? Substitution cost is we are moving from di minus 1 to j minus 1. This is I and this is j. So we are moving from di minus 1 to dj minus 1 to dij. We say the substitution cost is 2. If both si and sj, these both are unequal, then we apply a substitution cost of 2 here. We get a substitution cost 2 here. So we apply a minimum, right? So when we go by this path, it means that if I am going from this path, I have already deleted I. Now when I am moving from this, I need to insert one. So I have already, from moving here to here, I have deleted. From moving here to here, I need to insert one, right? So I am moving from here to here. I am moving from this di minus 1 comma j to dij, right? Di minus 1 comma j to dij. So this is already 1 here. I insert 1, so this becomes 2. So I get a 2 value for this. Okay. Similarly, if I move from here, right? So I have already inserted E here. In this place, I am on a state that I have E, right? Now I have to delete I. Okay, so I am adding 1. So this means this is 1 plus 1, it becomes 2 here, right? So in this way, I will take a minimum of all these. So minimum of these will be, again it stays same as 2, right? Similarly, if I have to move at this place, I can go from this point. Okay, if I am going from this point, I will again delete n. So initially I was having I and n, I have to make it E. This is the source, this is the target. So for input string in, I can again delete I and substitute e in place of n. So this can be, I will delete I, okay, and for n I will substitute, delete and substitute e. For n I will substitute. So this is one path, right? So it means I will delete I, okay, this I will move from here, delete I, and then I will delete n, sorry, I will substitute n. So this is one path. So when I am substituting n, I will add 1 plus 2. So this 1 plus 2 becomes 3. 1 plus 2 is 3. So another path will be, in place of this, I will again delete n. For n I will apply delete, okay, and then for e I will apply insert, okay. So I delete n here, I delete n, from here I delete n, and then I insert e. So again, so at this place the cost is 2, cost becomes 2 plus 1, that is 3, okay. Again, instead of this I can go for another option. I have I originally, I delete, okay, I have right, I will insert e, okay, then I will delete I will delete n, right. So I will insert e, I will delete I, then from here I can obtain the value of the next block, that is 2 plus 1, that is equal to 3. So minimum of 3 is again 3. Alright, so in this way we can proceed, we can fill up all these values. So this is 2 here, this is 3 here, right. Now again at this place I will be either adding 1, okay, so this is 4, right. From here also adding, from here I will be adding 2, but at this place let us see what happens at this place, okay. So when I am substituting e with e, so the substitution cost, this becomes 0 here, so this one becomes 0, the deletion cost, okay, from here, sorry, insertion cost, I am already deleted all these things, then I insert e, so that means I am moving from this to this place. So 4 plus 1 is 5, sorry, the previous one is not 0, it is 3, and the insertion cost after deleting all these is 5, this is delete, this is insert, and then we insert one, we insert, okay, then we delete. So deleting 1 from 4 will give us again 5, so we again take the minimum, so that is equal to 3. So at this place we see that this is 1, this is, sorry, this is 2, this is 3, this is 4, but this becomes 3 now, alright. So at this place we see that the cost is same and we are moving from, so in order to like trace from where moving we are getting this 3, we can, so we can trace this path. So this path is giving us the minimum edit distance of the string I N T E to the string E, right? So that means I need to delete only 3, okay, INT, and then insert E, that will be 4. If I insert E and then delete, then again 4. But if I delete 1, delete 2 and substitute T with E, so I am here inserting 1, inserting I, sorry, deleting I, then deleting N, then deleting T, right? This is delete, this is delete, and this is delete, and we don't do anything with E. Substitution cost is 0. So this is the minimum path that is being followed here, right? So in this way we can also trace from where we are getting the previous value. We can also trace that. So it will give a path. So we will fill up this, so this becomes like this, okay. When we trace, the path is like this. So we can change the algorithm a little bit. So this is the traced path, right? So we can change the algorithm. So we can note down from where the pointer at every location, from where the pointer is coming, right? So if the value we are getting from this place, we can store, right? At every place we can store the pointer value, okay. So we change the algorithm a little bit. We add, for insertion, pointer ij, we also add ptr ij is equal to left, okay. For deletion, we write down the pointer as down, and for substitution we write down the pointer as diagonal, right? So in this way, just slightly modifying the algorithm, we can also trace from where we are getting the path, right? So we get this path, right? And this is the minimum edit distance of value 8, and we can trace the path also. So at any instant, suppose I am taking this input and this is output from the table, I can see that this is the minimum distance, okay, and this is the path, right? So delete 1 here, substitute 1 here, substitute 1 here, substitute 1 here, right? So delete 1 here, okay, the delete I, substitute, substitute, substitute. So this is 1, this is 2, this is 2, this is 0. So this cost is now, total cost is actually 5. So the cost, this total cost becomes 5 here. And we also know the path कि हमें कैसे पहले delete करना है, then फिर हमें substitute करना है, फिर हमें substitute करना है. So this is the minimum edit distance algorithm with backtrace.